Hey everyone, this is supplemental instruction for CS11. It is March 20th. Um, so no one's here in the room right now, so I'm just gonna go on recording and go through what we would cover. Um, and so essentially, I wanted to get feedback from the midterm. If there was anything that you didn't understand, that if you were here live in the recording, like if you had joined Zoom, which I don't see anyone on the Zoom session, um, uh, or if you were physically here, we could go through the midterm and pick out any of the questions that anyone had trouble with. Um, but no one's here. So I'm going to assume that all of you did fantastic on the midterm. If not, feel free to email me at cs11 at carterfrost.com, or show up to a session and I'd be happy to help you out. Yeah. So then the next thing that I wanted to go over was a refresher on the CN and getline streams. That was talked about in class. So essentially, CN is going to give you the first thing that matches the type that you're trying to consume. So so let's open up the replit. So it's using namespace std. Get rid of this. So if I make an integer, if I make an int, and let's call it t, why not? If I see cn, and then I'm consuming from cn, I'm getting from the keyboard, and then I'm going to put it in t. So what cn does is cn is always going to get the next white space delimited thing that matches this type. And when, for example, if you typed in a letter here, bad things are going to happen. So let's just print out got t. So let's run this. Let's do it once where we give it valid input. So 2. So we got 2. Great. So now let's run it and let's give it something that's not like a. See, we got 0. Got something weird. So sorry. So essentially, what happens is that it didn't get something that was an integer. It got this letter a here, and so in this case, it gave us 0. But we can't really guarantee that. But imagine now that I had a string called t, and let's call it s instead. And let's initialize it to something that's bad. Something that's really obvious that if for some reason it didn't get set, that we're going to see something obvious that we got bad. It's always good to have a sentinel value that's really obvious that something bad happened that you didn't assign over the top of it when you were making a variable. So here, also something that I'm doing, I should probably prompt the user. So cout, and I'm setting into the stream, enter stuff. There we go. Now we have a prompt. Prompts are good. So this is a test. So notice how we only got this. Now, if we did subsequent CNs, right, then we could get the rest of it. But maybe I wanted to get the whole thing that the user typed in, and that's where getline is really going to be useful for us. So CN is only going to get us things that before the next space. Greetings. So then here, we're going to consume two things, and then we're going to print them both out. So let's run it. This is a test. So notice now we got both of the things, because what happens is that what was left over after the first one, S got this. So I'm going over the difference between getLine and CN, or yeah, the streams. So actually, let's resume recording. Hey everyone, a question was asked about how we would convert a string into an integer. And so right here we actually have something in base 2, but let's do 1, 2, 3, 4. And you can pause the recording, and you can look at the code and look at this to figure out what's going on. Okay, moving on. So did you talk about square brackets and arrays?
Yeah, I think we just got to that at the end of.
Right, because I see it in your slide.
At the beginning of tonight.
Okay, because I see it in your in the pre-midterm lecture. So.
I don't know if we finished that.
Oh, okay.
If we do cover, go ahead and talk about it, because if at worst we're going to finish it tonight.
Right, they'll be well prepared.
Yeah.
Okay, cool. So so essentially, the only thing that we've been introduced in the having how to stick lots of things together, like lots of characters together, are strings. The thing those strings aren't quite a bunch of characters together. They're a little bit more of a complex structure than that. But imagine that if I wanted to be able to store a ton of integers together, and I wanted to have some kind of relation to them. Like maybe the user's going to type in lots of numbers, and I want to be able to store them not as separate integers, but all in sort of one spot. Arrays are a really good way of doing that. And the generic explanation that a lot of people use for arrays is imagine that you have a very large lineup of mailboxes, and that each of the boxes can hold mail, and they all have unique indexes, like ways of calling each other. But at that spot, they're all called the same thing as well. So let's go to Replit, our handy dandy Replit, and let's just make a new. And so the way that we make an array is like this. So we have the type that we want it, we have the name we're going to call it, and then we have how big we want, how many slots do we want in it. And so I could say like array, I'm not sure, let's make a for int I equals 0. Get rid of this. So I'm I is smaller than oh right, this is C++. Sorry, wrong language. So one of the unfortunate things about C++ is you got to keep track of how big you made something. So most of the time you'll be like int array size equals 10, and then in here, that way later you know how big it is. So you know how with strings we can call like the dot size? That's built into the string class. So somebody essentially, this is all they did. They essentially have a variable that keeps track of how big it is, and when you do that dot length or dot size, all it does is it gives you that variable. And when we do classes, we'll actually have an activity where we'll rewrite a class that we have. Okay, so for int I is bigger than size, or smaller than size, and then I'm gonna cout the array. namespace std. Okay, great. Pink. What is wrong with this? Oh, oops. I want array at 0 is 99. At 1, 88. Let's see if we get garbage. Cool, we get garbage. All right. Okay. So one of the things about C++ is that you're not guaranteed that when you make a variable that the value that's inside of it is 0 or is empty. Most of the time when you make a string, it's gonna give you an empty string, but there's no actual guarantee. So you should always, whenever you're making a variable, you should always initialize it to something. And the same goes for strings. Is that the string? The same is for arrays. Is that you should go through every position, every spot, and make sure that it is 0 or some kind of sentinel value that you know is not valid. That way you can look at it and go, oh, I've never set this before. And so in the modern version of C++, we're allowed to do something like this. Oh. I don't know. Can I change the compiler? So you know when you say like --stl CS11, like when you're in G++, that's going to allow you to use this syntax. I don't know why Replit isn't compiling in that version right now. Okay, so if you're running on an old system that doesn't allow you to do it, essentially all you do is you do this. You have a for loop that goes through every spot and empties it out. So in a lot of old code, you'll see this like right after somebody makes an array, you'll see the for loop. On a newer system, you can just do that equals curly braces and then the initial value that you want everything set to. So okay, and then we can manually go in and set those spots. So I have a structure that has 10 spots in it that can all hold integers. And then in each of those, I have a for loop that goes stuff is 0 in here, stuff is 0 in here, da 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 da. And then I go, okay, let's go back to that one spot, and we're going to stuff 99 in it. And then in the next spot, we'll stuff in 88 into it. And then I can print out that structure. Just how I would print out like a string, I go one at a time and print one spot at a time. The cool thing with this is that this allows you to group data into one structure. And so, like if you had user input that you were just consuming, you had a while loop that while the user didn't enter in the number -1, you kept consuming input and then putting it into an array or some kind of structure like that. And then now you have all of the user data all in one spot. And then you could print out, or you could then go through all of these and add them together or print them out like, hey, the user typed in the number 0 5 times or something like that. And so this is useful because this saves us from making an unknown or an infinite number of variables because maybe you don't know how many the user's going to make, but instead you have one variable that can hold 10 things. So yeah, arrays are super duper useful.
So the operator is for array is ARR.
No, that's the name. That's the name that I gave it. There's no operator. I mean, besides like these square brackets. So in the sense of when you're making it, these square brackets are defining how big it's going to be. So you have your type, you have your name, you have your square brackets to how big you want it. So it's going to be 10. Right? It's going to be of size 10. Yeah, I could have just typed 10 in here, but it's better to have a variable so you know how big it is. And then after you do this line, you can now do the name, square brackets, and then the number. And the number has to be within these range. And just like strings, everything starts at 0. So what is the biggest number that I can stick right here?
10.
It has 10 elements, and we start counting from 0. What's the biggest number I can stick right here?
It's pretty big.
No, in this context, though. Okay, so what if I instead said 5? I can hold 5 things. And I start counting at 0. And these are the indexes. So this, I call this ARR, and I say ARR square bracket at 0. This whole thing gives me whatever's chilling here. So right here, this is the index. So what's the maximum index if the array is only has 5 elements that I can hold? 5. The biggest index. So if I wanted to access this guy, what would I put inside the square brackets? 4, exactly. So essentially we start counting at 0, and this is a common problem. All languages except 1, and maybe 2, start arrays at 0. We count everything from 0. Now, when you ask a computer how many processors does it have, it literally says, I have 0, 1, 2, 3 processors. How many processors actually are there? There are 4, right? Exactly. And so, yeah, we start counting at 0. So here, in this context, now if I go back to 10, what's the biggest index that I could have here?
8 or 9.
9. We start at 0 and then we go to 9 because there's only 10 elements. So essentially, whatever this size is, we're going to minus 1. And so in the for loop, we're okay because this is a less than. If it was a less than equal to, your program would crash because you would be trying to access. Because when does this for loop stop? What's the number? What's the number here? Last time through, and actually, let's just do this. Let's say 3. So we start at 0. Is 0 less than 3?
Yes.
Okay. We run the loop. We print it out, and we hit here. We increment here 1. Is 1 less than 3?
Yes.
So then we run through. We hit the loop, and then we increment, and then we have our 2. Is 2 less than 3? Okay, and then we increment is 3 less than 3. Great, and we exit loop. So what was the index when this ran the last time? 2, exactly, and 2 is the last index. If for some reason I was silly and did this, my program might crash. It might not. It didn't crash. You should not expect the behavior of a crash. Because sometimes there's enough memory that's given to your program and you're going somewhere else. So you should always just, this is check your bounds before you wreck your bounds, as Steve said. Yeah, make sure, trace it out, run it through your head, before you write it, because you might be trying to print out one extra. And sometimes your program will crash, and sometimes it won't. That's a problem. Have your program run all the time. Yeah, so arrays are pretty nifty, and we don't necessarily just have we can make arrays of any type. We can have arrays of strings. We can have arrays of booleans. We can have arrays of floats and of doubles, and actually. We're going to make our own data structures later in this class, and you'll be able to put something here that is something that you invented yourself. So you can have an array of something that you invented by yourself. Oh boy. So yeah, arrays are pretty nifty. Any questions on arrays? Cool. And so the thing that keep in mind with arrays is that before you use the array, you have to know how big you want it, and so that can have drawbacks because maybe you don't know how many things the user's going to type in. And so one of the things that some people will do is they'll have something called a partially filled array, where they keep track of how much of what's valid and what's invalid of the array. And then it's just another integer that you say like, hey, I got this many things from the user typed in. And in other languages, most languages call this structure an array. But for example, in Python, we call this a list. A list. But most languages just call it an array, and that's good. Okay, great. Okay, I'm going to use the F word. Functions. So you know how we've been using like all those dot notation for like when we were playing with strings or playing with other things. Those are all functions. When we called anything from the math library, those were all functions. So like the POW, that's a function. And a function is just a piece of code that can be called over and over again. The idea is you don't have to reinvent the wheel every time you want to use it. That you program it once and then you're good. One of the cool things about a function is that it can take parameters or arguments, depending on who you're talking to. It's the same thing. Arguments and parameters is the same word. That allows it to change how it behaves. So imagine, and this is actually how it is in code, that the plus operator is actually a function. What it does is it looks at the things on both sides of it, and those are its parameters. And that allows it to then know what to do. Oh, I need to add those two things together, and it gives back the result. In most cases with C++, the functions that we're going to be using, that we're actually going to be able to affect, are going to have the name of the function and then a set of parens, and everything you want to give the function is going to be inside of those parentheses, and there's going to be commas separating them. Yeah, so functions are really neat, and we're going to be learning probably next week how to make our own. Yeah, cool. So, any additional questions at this point? You guys pretty solid.
Pretty good.
Right?
Yeah, well, the first one, 4.1, where you write a program with loops and mutes, and so 5 things. And one of them is all the power of 2, starting from 2 to 0 to up to 2 to 20.
Yep.
And so it's a program that computes, but does that necessarily mean like physically computes or just prints it out the screen?
Well, I would assume that you should probably print it out to the screen. But yeah, I mean, computing is the same. We call it POW function, and then
Okay. I didn't realize you could use those. But
yeah, go for it. Yeah.
From 2 to 0, I just did the C out 1 before.
Yeah, don't hard code anything. You should be able to just make a for loop that does all of it for you. Okie dokie. Pause the recording. Not wasting people's time. Pause my music. Hey everyone. So something I noticed that a lot of people struggled with was when the word literal was used. The word literal means it is written exactly as is meant to be expressed. So when I say the literal of the number 2, right, that's the literal of 2. But if I ask for the character literal of the number 2, it's going to be in single ticks. Single ticks indicates that it's a character. So like the character literal of the letter A, of the uppercase letter A, is with single ticks. The reason why this is really important is because sometimes they'll ask you a question, and then if you mix up the literals, it's not gonna mark you as having the correct answer. Let me show you really why. What's the integer value of 2 verse? Actually, let me just ask this question: is 2 equal to the character literal of 2? And the answer is no. If we look back at the ASCII table. If we look back at the ASCII table, we can see that the number that the character of 2 is 50, right? So this is going to be false. But if I had said something like this, it's 50, that's going to be true. And this is weird, right? I mean, the first time you look at it, you're like, what's going on? Just remember, everything in the single ticks are characters, and those are going to be, you're going to look at the ASCII table to figure out who belongs to what. And then if they ask for a string literal of the number 2, that's going to be in double quotes, right? So strings are with double quotes, characters are single ticks, and then just like the normal literal is going to be with nothing. So like the literal of 2.2 is going to be 2.2. But you couldn't just say like literal of A, because that doesn't make sense. A isn't anything. It's looking for a variable called A, and it can't find it. And so you would say something like the literal of the character A, or the literal of the string of A, are going to be like that. Cool. So yeah, that's something that I've seen a lot of people struggle with. You should always match the type that your variable name is, or whatever you're assigning it to whatever the literal that you're assigning it to. So you shouldn't have like a string where you're trying to set a string to the character literal of A. It might take it, it might not, but you should really match the type. So if it's asking for a string, give it a string. Because what happens if it's more than one thing, right? A string can be like ABC, right? That's no problem. But a character is one letter, and so you're gonna get something bad happening. You don't want to do that. So a character can only hold one letter, or one character, but a string can hold lots. And so that's the issue that you're going to run into if you're not careful about this. So double strings, single text characters, and then nothing would be like the actual value itself that you're looking for. Cool. Hope that helps. And